Hello and welcome to our screencast Equalizing a 56 GBaud PAM4 signal. We will do such equalization with the help of our SHF-4 filter and with the help of the SHF-Optimizer software. So let's begin by starting the software. What we have in front of us now is the GUI of the SHF-Optimizer software. It has many knobs to turn and many infographics to see, and we might need to go through that one by one. But as a starter, I would like to begin with the three eye diagrams on the right hand side. The first, or the top eye diagram, is the eye diagram of the source. The source, one would understand, usually is an AWG or an BPG. One could get this eye diagram by importing the real data from your scope. It can either be by a CSV file or by directly connecting the software to your scope, or one can import the data just by using an ideal waveform which is built in to the software package. The middle eye diagram is the eye diagram of the DOT, or better, it's a signal after the DOT and after the probe. So usually this is a signal one would like to optimize. How can we get this eye diagram into our software? Again, we can either import it from the scope, or we can just degrade or manipulate the signal from the source by loading S2P files into the software or by using built-in filters like a Bessel filter. The third eye diagram here is the signal after the equalizing filter. Later on in this video, when we did the optimization, it is supposed to be of better signal quality than the eye diagram in the middle. In order to do so and to understand what we do in this little video, let's have a quick look at the setup. The setup is comprised by the same three elements as we just discussed in the GUI. The source is comprised by our SHF bit pattern generator connected to our SHF DAC. For these instruments, one have to mention that they can actually generate signals with pre-emphasis. In this very setup, however, we do not want to do that because we want to show the capabilities of the equalizer and not the capabilities of the pre-emphasis of the BPG. So what we feed into the device under test is straightforward PAM without any pre-emphasis and with equal eye openings. The device under test is a 3-meter SMA cable. The speed in our setup is 56 GBaud, which is 112 Gbps PAM4, and at this speed a 3-meter SMA cable can be of very good use to downgrade or degrade the signal quality. The output of this SMA cable is then to be fed into our equalizer. This FIR filter is supposed to enhance the signal quality massively. In order to start the optimization process, we have to get a signal into our software first. As explained earlier, there are many options to do so, but in order to be most realistic in this experiment, we take the signal from the output of the device under test. This has one consequence. That means that we are not making use of the functionality to mimic the device under test. That means in the next pictures, the output signal from the source is the same as from the device under test. The only reason is that we just have the output from the device under test, and this is a signal we want to optimize. As the scope is already connected, we can just change the waveform from the ideal waveform to the measured data, click Get Trace, and the acquisition process is started. As mentioned before, the eye diagram from the source and the eye diagram after the device under test are now the same. As a proof of concept, we can also have a look at the scope measurement. To me, both signals look very much the same. No wonder it is actually the same signal which is displayed. Anyway, the third eye is worse than the other two. In fact, it's pretty much unusable. So let's optimize it. In order to do so, let's have the SHF-Optimizer calculate the optimum tub settings for us. After the software calculated the new settings, the tubs are applied immediately to the GUI as well as to the device itself. We can see that the eye on the right corner opened up. Let's again compare the eye predicted by the software with the eye really measured by a scope. To me, both signals look very similar. Comparing both scope waveforms, we see that the signal went from unusable to usable. In fact, with our SHF error analyzer, we managed to measure 0 errors at the below signal. I hope you found this little screencast helpful. If there are any questions, by all means, please let us know.